So hey everyone, I am Satvik. Welcome again to Kepler Codes. Today we are going to solve another CodeChef contest. So let's quickly start with the first problem. Okay. So the first problem is qualified or not. The problem statement says, okay, so there are 2% participate in a first round of coding competition organized by Coding Club IIT Roper. To qualify for the next round, a participant must defeat both Tan Minati and Webby something. A participant can defeat another participant by solving at least twice the number of problems as the participant. Given that the first person have solved X problems and the second one have Y problems, determine whether a participant who solve N problems can participate in the next round or not. Okay, so input format, we have given three integers N, X, Y, and we need to tell whether a participant solving N problems can defeat the participants solving X and Y problem respectively. Okay. Also, yeah. So essentially in the first question, the main thing is that they will give us three numbers X, Y, Z. No. I think N, X, Y. Okay, sorry. They will give us N, X, Y, where N is the number of problems solved by first participant, X by the second and Y by the third. Now we need to determine whether the person solving N problems defeat the person solving X and Y respectively. And the main condition given for defeating a person is that they need to solve at least 2 times the problem solved by the defeated person. Okay, so that means we just need to check whether N is greater than equals to 2X and N is greater than equals to 2Y, right? Yeah, so it's a pretty straightforward approach. Let's just quickly code that. So just I need to do this only. N should be greater than 2 times X also. N greater than equals to should be also N should be greater than equals to 2 times Y. Yeah, if this condition holds, then I will just print yes, else just print no. Let's check it. Yeah, so I think it should work. Yeah, it's working. Now let's quickly move to the second question. Okay, so it's the coding streak. Yeah, again the complicated names. Let's just avoid that. A person loves solving problems. You are given an array A of size n, where AI represents the number of problems solved in the ith day. A streak is defined as a sequence of consecutive days where the person solves at least one problem every day. Okay. A streak is defined sequence of consecutive days where the person solves at least one problem a day. Find the length of the longest streak present among n days. Okay. So basically, in this question, they have provided us with an array. Okay, where each element of the array represent the number of problems solved by that person with complicated name. Let's avoid that. Each element of the array represent the number of problems solved by that person each day. Okay. So and there is also a term called coding streak. Coding streak is actually the number of days where the longest number of days where the person have at least solved one problem. Okay, for example, let's take the example 0 5. Okay, let's create as by 1 2 3 1 0 2 3. Okay, so here this is actually a streak because from day 1 to day 4 the person have solved each day he have solved at least one problem, so this is a streak. But at the 5th day he have solved 0 problem. That means on the 5th day the streak broke. Again from the 6th day another streak start. So this is a streak of length 2 and this is a streak of length 4. Now the question asked us to provide the longest streak from the array where each element represents the number of problems solved per day. We need to provide the longest streak. Okay, so the approach would be like this. Every time, basically, what is the main point? That whenever I encounter a 0, I need to break the streak. That means on that day he does not solve any problem. So that means I need to look for zeros. Whenever I got 0, I need to break my count and then calculate whether it's the maximum length of the streak or not, or else I need to increase my count. right? So I will just traverse the array. So this is the for loop. For example, I need a count variable that will count my current streak, not the longest streak, and need an answer variable that will hold my longest streak. Okay. So if my array of I is not equals to 0, that means I just increase my count, right? That means my streak increases. Sorry, this is actually a T. Else means my array of I is actually 0. That means I did not solve any problem on that day. That means in that point I need to break my streak. Now before breaking, I want to check whether the current streak is actually the maximum streak or not. So I will just perform if my answer stores the maximum value. That means answer should be maximum of count and answer. That means I will store the maximum in my answer and then just do count should be 0 and move forward. That's it. Now let's quickly code this. And also there are test cases given, so yeah. Okay, so first they will provide us with the length of the array, then the elements of the array. Yeah. Now the main part begins. I just loop through the array. I think yeah, I can also do it like this. Yeah. Okay, so the two variables I need are basically answer storing our maximum value and count that will store our current streak value. Okay, so if it is actually double equals to 0, no, let's do the preview. Okay, so if if it is double equals to 0, then what I need to do, I will just check whether the current count is maximum or not. Answer should be max of answer comma count. Count again will be 0. Yeah, else just my count will increase. Also after getting out of the loop, I again need to check that answer should be again maximum of answer comma count. Yeah, now just print that. I think it should work. Yeah, it's working fine. Now let's submit it. Yeah, it's working. Now moving towards the next question, that is what is this? A, B, B, C, C, D, D. Yeah. During Advitiya, the coding club is designed a digital banner made up of English letters. Each letter can appear in the uppercase or lowercase. You are given a string S of length n denoting the current state of the banner. Okay, so we have provided with a string of length n. To maintain visual uniformity, the design team allows two types of transformation. Operation 1, you may convert any uppercase letter to corresponding lowercase letter. Okay, so choose any index, then I can convert uppercase to lowercase. You may choose exactly one lowercase letter and convert all of its occurrence to another lowercase letter. Okay, for example, if S is A, B, B, C, C, I can choose exactly one lowercase letter and convert it to A and convert it to E. Okay, and I can do this operation only once. Okay, the score of the banner is defined to be the maximum number of occurrence of any single lowercase letter present. Okay, so basically in the third question, they will provide us with an array. An array consists of both uppercase and lowercase letter. For example, let's take the name of the problem. Yeah, A, B, B, C, C, D, D. Okay, like this. A, B, B, C, C, D, D. Yeah, they will provide us with a string can contain both uppercase and lowercase letter. Now there are two types of operation. First one, that I can choose any uppercase letter and convert it to lowercase letter as many times as I want. And the second operation says that the second operation can be performed only once, and the operation we can choose any one lowercase letter and convert it to another lowercase letter. That means, for example, here let me choose B, small b. Okay, I can only choose lowercase letter. Now let's convert this B to A. So I will convert all the occurrence of small b to A. That means the string will become A, B, A, C, C, D, D. Yeah. Now at end there is I think there is a thing called a score. The score of a banner is basically, let's just again check. The score of a banner is the maximum number of occurrence of any lowercase letter. Okay, the score of a banner is maximum occurrence of a lowercase letter. So in this case, the maximum lowercase letter is A and A, so the score will be 2. Okay, so using these two operations, I need to tell the maximum score. Okay, so in this question, first of all, the thing I need to first do is that convert all the uppercase to lowercase, because that thing can be done as many times as I want. Yeah, so first of all, convert all the uppercase to lowercase. Right, operation 1, convert every uppercase to lowercase, so the string will become AA. Okay, let's take the previous string AA. Okay, so AA, BB, CC, DD. Okay, convert all the uppercase to lowercase. Now how can I maximize the maximum occurrence? How can I maximize the occurrence of a single lowercase letter? First of all, I need to check which is already the maximum lowercase letter. Okay, first of all, I need to check which is the already maximum lowercase letter. That letter I won't change. The thing I need to do is that I will convert the letter having the second most occurrence into the letter having the maximum occurrence. That means in this case there are 2A. Okay, let's just change this string. Let's make it imbalance first. Okay, so there are 3A. Okay, so there are 3A. There are 2B, 2C, and 2D. Okay, so maximum occurring letter is already A. So I will take the second maximum letter. I can take any B, C, D. Then I will convert their occurrence to A. That means now I will have 5A, 2B, and 2C. This 5 will provide me with my answer, right? This 5 will provide me with my answer. Sorry. So that means essentially first I need to convert all the uppercase letter to lowercase if there is any. Then I calculate the frequency of each lowercase letter. Then I will convert the second highest lowercase letter into the first highest one. That means essentially I will add up the top 2 highest frequency letters. That's it. Okay. So let's do this. One second. I need to copy this. Yeah. Okay. So these cases are there. Solve. First, I think they will provide us with the length of the string. Yeah. Okay. So first of all, convert all the uppercase to lowercase. This is for the ease. Okay. You can, if you want, you can directly put everything into the map. Okay. So for auto, let's convert it to integer first. Then I can compare the ASCII value. If you want, you can use string functions as well. Okay. Yeah. So I think the ASCII value of I think it should be less than equals to 90 if I'm not wrong. If it's less than equals to 90, that means the character is actually uppercase letter. So what I will do, I'll just remove 65 from it. Okay. That character be C, and C should be equals to X plus A. Yeah. Else C should be directly equals to IT. Okay, let me take a map first. Okay. Oh, sorry, it shouldn't be int, it should be char. Now m of C should be just calculating the frequency using the map. Now let's check whether our character is correct or not. Whether I have done the ASCII operations correctly. I can just check using this. Okay, check for a small one. So yeah, let's check. Okay, yeah, so I have done it correctly. So you can see that capital A is converted to small a, then there is small a, so there will be no changes. Then there is small b, then again capital B is small b. Okay, so yeah, this ASCII operation is correct actually. Now I have calculated the frequency. Remove this print. Now what I need to do is that I need to just check the maximum and second maximum from the map. For this I can just easily traverse the map. Let the maxi and second maxi be like this. let them initialize by int minimum. maxi2 should be okay. So let's traverse the map. Yeah, so if m dot second is actually greater than max1, then it should store my maximum value. Max1 should be m dot second, and maxi2 should now store the value of max1. Okay, so no, sorry. First of all, I need to store the value to max2, right? Otherwise, I will lose my value. Okay, so it's maxi, no? Not max. Maxi2 should be equals to maxi1, and maxi1 should be m dot second. I can just continue here. Okay, so another thing you can do easily is that rather than doing this, obviously this is a better approach. Rather than doing this, you can directly store all the value in all the frequency inside of the map in an array, then sort it, because the complexity won't change. Using a map already means that we have a complexity of big of n, right? So you can, another thing you can easily do is that just get every frequency, insert them inside of an array, and then just sort. Okay, continue. If our m dot second is actually greater than max1 and less than max2, sorry, less than max1, and m dot second is greater than max2, then max2 should be that. I think, yeah, all the cases have been handled, no? Continue. If it's less than max2, then yeah, then it won't change. Okay, so now my answer should be max1 plus max2, because max1 stores the actual maximum value and max2 stores the second maximum value. So another thing I need to check is that one of the edge cases I can say, for example, if all the values are same, then what will happen? Then max1 and max2 should be same. Yeah, if all the values are same, then max1 and max2 should be same. In that case, there can be issues. Or no, sorry, very sorry. If there is a single frequency, for example, let there be a and 3, there are 3 a's. Yeah, let me again come here. For example, there can be edge case like this: a. Okay, so what will our code do? The first thing I need to do is that convert all the uppercase to lowercase. So it will be a, right? Then I will count the frequencies. So in the map there should be 4a, a and 4. Now if I run my problem, what will happen? There is only one value, 4. So my max1 will store 4, right? So what will my max2 stores? It will store minimum int min. So I need to check for that. That's it. If max2 is actually int min, then max2 is just 0. I won't perform the second operation at all. Sorry. Now you can just see out max1 plus max2. It should be working. Okay, let's check. Oh, sorry. It what? Why it's m? It should be it. Very sorry. Yeah. Another issue I found, just if iter2 less than max1, iter2 yeah, less than equals to max1, greater than max2, yeah, then only it will happen max1. Yeah, what's the error? Oh, okay, the second spelling is wrong. What is SEC? Okay, also one thing, rather than map you can actually use an array as well. Maxi. again maxi, huh? There are various mistakes. If okay, so again maxi, C and maxi, yeah. Okay, let's just check. Yeah, so for the first one it's working. Let's check for all the test cases. Okay, yeah, it's working. Now let's just submit. Yeah, so it's done. Now moving towards the fourth question. I think, yeah, the fourth question, accommodation. Okay, so there are B boys and G girls who would like to take accommodation in a hotel. A hotel has infinitely many rooms and each room with a positive number of occupants. It must contains, there are some conditions, at least there should be X boys, there should be Y girls. It can contain at most N people in total. Okay, so there are X boys, Y girls, N people in total. Okay, B boys and G girls. Determine the minimum number of rooms required to accommodate all B plus G people while satisfying these constraints. Okay, so our task is to find, okay, so let's just formulate it in this question. In the fourth question, we have provided with B boys and G girls. We need to accommodate all the boys and girls inside of a hotel room. There are infinitely many rooms, so we can use as much we want. After that, there is given X and Y. We need to ensure that each room should have at least X boys and Y girls, and the room capacity is N. That means each room should have less than equals to N person. Now our task is to find minimum number of rooms to deal with this. Okay, so how can I do that? First of all, first thing, important thing is that in each room I need to at least accommodate X boys and Y girls. So first check this, if X plus Y is actually less than equals to N or not. Because if X plus Y is greater than N, the room capacity is N. If X plus Y is greater than N, then the answer is -1. Simply we cannot follow all the conditions. Okay, so first check this. Okay, after that, what can I do? The first time I saw this problem, the first thing struck to my mind is binary search. Though there is, I think, a mathematical solution, you can check it later, but binary search is more intuitive for me, right? So I will just loop over various values of room that can be there from, I think, 1 to 29, which should be enough. I will loop over this and just try to check if my current binary search answer, so my current answer is possible or not. If possible, then I check for less. Okay, so for example, binary search give us a value k. Okay, so I need to check whether all the conditions are is possible within k rooms or not. So I need to check if I can accommodate B boys, G girls inside k rooms such that it follow all the conditions. So first thing, what should I need to do? First condition is that I need to accommodate at least X boys and Y girls, right? Boys and Y girls. So first of all, basically put them inside of the rooms and let's just check how much space is left. So there are k rooms, right? So X plus YK, total initial requirement is this. I will put X and Y in each room. So this many children are left. Sorry, these many children are already occupied. Now how many children are actually left? The number of children left should be B plus G minus this, right? Already occupied children, B plus G minus this. Now I need to check the amount of space left. Each room there is a space of N, so I will just do this, N minus X minus Y of K. This is the amount of space left. I just need to check whether B plus G is actually the remaining amount of children is less than equals to remaining amount of space or not. Okay, but this is a primary condition, but there can be another condition that's very important. First of all, we cannot we need minimum amount of room, but we cannot actually have as many room as we want, because if we have, for example, again take k rooms, we need to have at least X boy and Y girl in each room. So there can be cases where the number of rooms is so high that we cannot actually accommodate X boys and Y girls in each room. So we need to check another thing, that is x plus y of k should always be less than equals to b plus g. If x plus y of k is greater than b plus g, that means number of rooms are too high to accommodate x boys and y girls in each room. Okay, so this is another condition. In this case, I also need to reduce. Okay, so that means what should my helper look like? Sorry, I have already discussed about the helper. Now, how will my binary search work? Okay, so I will just loop over. Sorry, 0 is not possible. 1 to 1e9. I will just loop over this. For any given value k, I will check. Now, there can be three situations. Okay, first of all, I can accommodate everyone. In that case, I am planning of returning 1. That means, I can accommodate all the b plus b and g girls, b boys and g girls following the conditions. In that case, I will send 1. If the amount of remaining space is actually less than the amount of boys and girls, in that case I will send 0. And in the special case where the amount of room is actually high to accommodate x boys and y girls in each room, in that case I am planning of returning 2. So I will handle all the cases accordingly. Okay, so let's just start coding and then I will explain accordingly. Okay, I need to copy this. Yeah, so the input is, I think, bgxyn. Okay, so let's just move forward. Okay, so first thing first, I will just check if x plus y is actually greater than n. If x plus y is greater than n, then I can't accommodate the necessary condition. I can have the necessary condition of at least x and y, x boys and y girls in each room. So in this case, just cout -1 and L. Okay, so now I will just start my binary search. Now before starting, let's just write the our helper function. So I think int will be better. int helper. I need everything. int bg int x. Okay, the first thing, convert everything to long. There can be situation of overflow, I am thinking. So convert everything to long. Okay, I am using LL. I will just declare it. bg xy and n, and also I need k. Okay, k means the current amount of room that I need to check for. So I need to first initialize this using LL equals to long. Okay, so first thing, the initial number of occupants. Okay, so let it name ini. It should be x plus y into k. Okay, if this initial value is actually greater than equals to my b plus g, that means it's condition 2. That means the amount of room is very high that I can't accommodate at least x boys and y girls. So in this case, I am planning to return 2. This is a special case. Else it's okay. I will just this is the initial amount of boys and girls I have already occupied the necessary conditions. So the remaining amount of boys and girls is b plus g minus ini. Okay, so long remaining people is b plus g minus initial value, and remaining amount of rooms are remaining amount of spaces, then space should be, each room can contain n people, n minus every room have already occupied x and y of k. It should be like this. Yeah, so if remaining people is actually less than equals to remaining space, so remaining underscore space, space, return 1. That means it's working. Else just return 0. Okay, so now coming to the binary search part, our low value is 1. Let the high value be 1e9. If it's fill sort, then we can check later. 1e9. Now looping through it. while those okay, one thing, let's also initialize our answer. Initially it's -1. Okay, uh, calculating mid one thing, 90 m should be low plus high by 2. Now okay, so and the operation 1, I will just check whether using m I can accommodate all person. I will just check it using my helper. So it should be helper of, what are the parameters, b, g, x, y, n, m, b, g, x, y, n, m. Yeah, so I will check using m amount of rooms I can accommodate all the people or not, following the conditions. Okay, and there should be op2. No, let's not do like that. Okay, so if op1 is actually operation 1 is double equals to 1, that means yeah, I can do that. That means my answer should now contain m, and after this I will just check to my left, right? If using m rooms I can already occupy all the person, then what should I do? I will just copy this to my answer and move towards left. Okay, because now I will check for fewer number of rooms if it's possible or not. So I will just move towards left. That means my high should be m-1. Okay, continue. There can be cases like if op1 is actually double equals to 0, that means I am not able to that means using m rooms we cannot occupy b plus g person, right? If operation 1 value is 0, that means our binary helper is sending back 0, that means we cannot accommodate all the person. That means I need to increase the size of the room, or no, sorry, I need to increase the number of rooms. So I will just move towards left. Sorry, very sorry, I need to increase the amount of rooms. That means I will move towards right, towards in the right hand side of my current middle value. So yeah, low should be m+1 and move. And coming to the last case, I can continue. Now coming to the last case, where my returning value will be 2. If it's returned 2, that means the number of rooms are too large. So I need to again reduce. So I will just reduce. That means else h should be m-1. Okay. So yeah, just print the answer. The error, where is the error? Okay, so it should be multiplied by k. What? Okay, this should be written x plus y is greater than n. There should be return -1. Okay, so there are some issues. Let me check first. Okay, 29, answer -1. So high minimum by middle value is this. Operation 1 helper b, g, x, y, n, m. b, g, x, y, n, m. Yeah, operation 1 answer should be -1. Initial value is, if I first accommodate these persons, return 2. Remaining people is b plus g minus initial value. Okay, so let me just check and I will again come back. Okay, there's some issue. Okay, so very sorry, I actually figured out the error. The main issue is that, sorry, this is not it. Yeah, so the main issue in this code is that basically in the return part, okay, the main thing is that I cannot directly check, okay, if initial is greater than b plus g. Initial means the initial occupant of x and y in each room. I cannot directly check it. I need to check it in two parts. That means boys and girls. Okay, so there can be cases where the girls and boys together is actually not breaking the conditions, but individually they are. So I need to do like this. Initial boys should be x times k, and initial girls should be y times k. Now if sorry, if any boys, sorry boys, there's a mistake. If initial number of boys is greater than b, that means the initial amount of boys required to fill all the k rooms actually greater than b, then it's not possible. I just need to reduce the number of rooms. That means it's the special condition to return 2. Else the same thing with girls. If initial girls is actually greater than g, then also the same thing. I need to check them individually. Okay, so previously I was just combining them and checking with b plus g, so yeah, it won't work. Okay, so there is no initial, so it should be initial boys plus initial girls, boys minus initial girls. I think it should work now. Let's check. If yeah, there's a missing semicolon. Yeah, it's working. So let's check for all the cases. It's working. Let's submit it. Yeah, so it's done. This is my approach. Actually, the first thing I thought of is actually binary search. There can be some mathematical approach using which you can directly calculate it, so feel free to check it. Okay, now coming to our last question of today, that is Advitiya coin. Yeah. Okay, so the solution is still here. Sorry for that. Now, in this question, during Advitiya, the coding club launched a brand new virtual stock called Advitiya Coin ADC to give participants a taste of real world trading strategies. The price of Advitiya Coin changes throughout the day and recorded in an array P of size n, where Pi represents the price of stock at time I. Okay, so we're provided with an array where each element represents the stock price at time I or the day, I think. A participant can perform multiple trades during the day following the rules below. A valid trade is one of the following: choose I less than j, buy stock on the ith day and still sell at jth index. And there can be choose index I less than j and sell the stock at index I and buy as index j. Okay, that means there can be two types of buying and selling. First of all, buy at I and sell at j, and also there is kind of reverse order of trade also. That means I can buy at j and sell at I, right? I can buy at j and sell at I. Okay, if a trade is made by choosing index ij, no other operations can be done on that day. That means in between ij I cannot perform any other operation. Each trade incurs a fixed transaction cost of k. Okay, so the profit should be sell price minus buy price minus k. Okay, a trade is considered winning if its point is strictly positive. Okay, that means I do not need to maximize the profit. If the profit is positive, that means it's a winning trade. So you're given P containing all the, I think the array P contains the stock prices, length n, the transaction cost k, and I need to compute the maximum number of winning trades. Okay, so basically in this in the fifth question, sorry, in the fifth question we are provided with an array P where each element represent various stock prices. Okay, each element will represent various stock prices throughout the day. Now we need to perform trades. There are two types of trades. First of all, I can choose I comma j such that I is actually less than j, then buy the stock at ith day price, sell it at on jth day price. Another trade option is that again I and j, I is less than j, I can actually sell at ith day and buy at jth day. That means I will actually buy, kind of I will sell then buy, like that. But yeah, this operation is also allowed. And another thing is that they have provided us with a value k, which is the fixed charges for each transaction that will be deducted. Okay, so the actual thing will be sell price minus cost price minus k. This will be my profit. Okay, so now I need to have a positive profit for a successful trade, and in the end of the day I need to provide the maximum amount of successful trade that I can do. I do not need to maximize the amount of profit. For example, let's take the examples. First of all, 5 1. Okay, so k is 1 1 3 2 5 4. Okay, 1 3 2 5 4, and my actual k is 1. Okay, so I can buy at day 1, I can buy at day 1 and sell at day 3. So My profit will be 3 minus 1 minus 1. This one comes from K, so it is actually 1, which is positive. So one trade. Now again I can buy at 2 and sell at 5 or 4. It does not matter. Let me sell at 5 because it comes first. That will actually maximizes. It's more optimal, because why to choose later values? Later values can be used for different things. So 2 to 5, my profit will be 5 minus 2 minus 1, that is 2. So it's also positive. That means another trade. After that there is no possibility because there is only 1 day left. So the maximum amount of I think good trade is 2. Another example can be 5432. 5432, and what is the value of K? K is actually 2 here. Okay, now in this case you can already see that the array is decreasing. So the first type of operation is not possible. Here I need to choose I and J such that I will buy at J and sell at I. So let the I be this, J cannot be this. First of all, J cannot be this because 5 minus 4 minus 2 is not positive. I can also, this also cannot be J. If I let this be J, that means fourth hour stock price be J, then I can sell at J. I can buy at J with price of 2, sell at I. That means my net profit should be 5 minus 2 minus 2 K, that is 1, which is positive. Okay, so the main thing regarding this problem is that I just need to have a positive profit, right? So what if I make my thought process is like this: I will maintain two value, maxi and mini. Okay, maxi and mini, because if I first of all DP will be very complicated, because here I need to calculate the number of good trades, not the maximum profit. So DP will be very complicated. Maximum, the thought process is calculate maxi mini. Anytime my maximum minus minimum is greater than K, I should do a trade. If my maximum and minimum is greater than K, then I should do a trade, because I should not wait. I should not wait anymore for making a trade, because I will be wasting my days, right? For example, let me take 13254 again. Now I will do using my algorithm 13254. I will have two value maxi having minus something, minus infinite, minus infinite, no, minus int max or int min. Maxi, let's just assume maxi will have int min value, my mini will have int max value. Okay, now coming to 1, my after coming to 1, my maximum value will be 1 and minimum value will also be 1. My minimum, let me just write it here, much more clear. Maxi mini, after coming to 1, my maxi is also 1, my mini is also 1. So what if I try to sell? Can I sell maxi minus mini minus K? Yeah, I can directly do this as well. Maxi minus mini is minus K. What is it? 1 minus 1, that is 0. 0 minus, my K is also I think 1. Yeah, my K is 1. 0 minus 0, 0 minus 1, actually minus 1, that is less than 0. So it's not a good trade. Now I can move to 3. Now what will happen? My maxi will change. My maxi will become 3, but my minimum remains 1. Now what is the profit? 3 minus 1 minus 1, that is 1. So now it's greater than 0. That means I should immediately make a trade, because already my maximum minus minimum is greater than 0. So I can make a trade. I should. So I will make a trade and increase my count. Now after this, again my maxi and mini should be 1, because in between I cannot perform any operations. So after performing a trade, again my maxi will be int max and my mini will be int min, and I will go forward. So again after this it closes. So again I come to 2, my maxi will again be 2, mini will again be 2. Can I perform a trade? 2 minus 2 minus 1 is again minus 1. I cannot. Now moving towards 5, my maximum will change but my minimum will remain 2. Can I perform maxi minus mini? Yes, I can. I will again perform. Then again the value of maxi mini will go to default, and then comes 4. Okay, so this will work. And now coming to a second type of operation, that means solving the second example of strictly decreasing array 5, 4, 3, 2, 1. Okay, maxi mini. Initially my maximum will be 5, minimum will be 5. Also K is actually 2. Can I perform? 5 minus 2 is actually minus 2, which is less than 0. So no, I cannot. Coming to 4. Coming to now I am here 4. My minimum will change. My maximum will remain 5. Minimum 4. Can I again perform? 5 minus 4 minus 2. What is it? Minus 1. So I cannot. Moving to 3. My minimum will again change to 3. 5 minus 3 minus 2 minus 1. What is this? This is 0. Again, it's not strictly greater than 0. So I cannot. Now moving to 1. What is it? 5. Moving to 2 actually. 1 is not there. I'm moving to 2. 5 minus 4 minus 2. Oh, no, sorry, actually, sorry, very sorry. I think 2 is also done, no? 5 minus 2, no, sorry, 5 minus 2 minus 2, that is 1. That is, in this time, this is greater than 0. So yeah, I should do a trade using this as I and this as j. My mini and maxi will give me that. So I will do a trade, my count will be 1, I will move forward, only one element left, so I cannot perform any other trade, the answer should be 1. So yeah, it's 1. So this question is actually quite tricky, but yeah, once you find the approach, it's very simple. So what I need to do, I will just take the input. Okay, take n, sorry. Okay, so there are two things needed. Mini should be int min. Sorry, maxi should be int min. Mini should be int max. Now just loop through the array of nums. Maxi should be max of maxi comma 8. Mini should be minimum of mini comma 8. Now just need to check this. If maxi minus mini minus k is greater than 0, that means I will just perform. I need to have a count that will count the number of good trades. I will increase my count and again set my maxi and mini to their default value. See out answer. Okay, no, sorry, count. Let's check it's work or not. Okay, so I have not initialized it now. Integer. Key is not declared. Okay, so I have not taken input the key. It's working. Let's submit it. Yeah, it's working. It's a good question. So this was the solution of today's problem of the day. The entire notes for this problem and the video shall be available at K+ website. You can visit there. The link is in the description and it's also on the screen. The notes and the video shall be available at the library section of the index under the resources tab inside the community section. So that's all for today's lecture. Thank you. Hope to see you soon in the next video.